So this is a National 4 chemistry video on Unit 2, and the topic for this video is hydrocarbons. So firstly, we need to know, what do we mean by a hydrocarbon? Well, a hydrocarbon is any compound made only of hydrogen and carbon. And if you're asked to give a definition, you need to make sure that you say only hydrogen and carbon. That's what it's made of, only hydrogen and carbon. They are found in nature in crude oil, and the different hydrocarbons are separated from each other in a process called fractional distillation. So you need to know that term, fractional distillation. And what happens during fractional distillation is you have this mixture of all these different hydrocarbons, and each hydrocarbon boils at a different temperature. So if you heat up your crude oil, when each molecule gets to its boiling point, it will evaporate or boil off, leaving all the other ones behind. And you can then collect the hydrocarbons based on the temperature at which they boiled at. Now, there are two main families of hydrocarbons that you need to know. These are called the alkanes, with an A in the middle, and the alkenes with an E in the middle. Okay, we have some differences and a lot of similarities. So firstly, we're going to look at alkanes with an A. These are straight chains made of carbon and hydrogen. The carbon atoms are connected in a chain, and the carbon atoms at either end of the chain form bonds to 3 hydrogen atoms, and the carbon atoms in the middle of the chain are bonded to 2 hydrogen atoms. And we've got 2 examples here. So we can see that first chain has 4 carbons in a chain. That's, if you were drawing it, you'd start with that. Then the 2 carbons at the end, you put 3 hydrogens on them, and the ones in the middle, you put 2 hydrogens on. That one on the right-hand side has 7 carbons in the chain. Look at the 2 at the end, put 3 hydrogens on, and then all the ones in the middle, add 2 hydrogens too. Now, alkanes have the general formula CnH2n plus 2, which actually seems like a complicated thing. And you do have to be able to write that down, CnH2n plus 2. But what that means is for every carbon atom in the structure, and say if it has 1 carbon, you have to work out the number of hydrogens by taking the number of carbons, n, multiplying it by 2, and then adding on 2. So if there's 1 carbon atom, n equals 1. 2 times 1 is 2, plus 2 equals 4. So the formula of an alkane with 1 carbon would be CH4. For a more difficult example, if there are 4 carbons, that tells you that n equals 4. To work out the number of hydrogens, 2 times 4 is 8, plus 2 gives us 10. So the formula would be C4H10. Now, when it comes to naming alkanes, there is a sequence that you have to learn. And it's the same naming sequence that you'll use for alkanes and for alkenes. Now, firstly, alkanes always end in the letters A-N-E. A-N-E. But the start of the name changes depending on how many carbons there are in the chain. So 1 carbon is going to start with meth. 2 carbons is going to start with eth. 3 carbons, prop, 4 carbons, bute, 5 carbons, pent, 6 carbons, hex, 7 carbons, hept, and 8 carbons, oct. And this gives us the 8 alkanes: methane, ethane, propane, butane, pentane, hexane, heptane, and octane. Now on to the alkenes with an E in the middle. These are very similar to alkanes, but somewhere in the structure, usually between the first 2 carbons, we see a double bond. So that means we draw two straight lines between the carbon atoms. So we have a carbon-carbon double bond, and it means that there will be two less hydrogen atoms in the molecule. In order to have a carbon-to-carbon bond, these need to have at least two carbons. So there are no alkanes that contain only one carbon. And the general formula for alkenes is simpler than for alkanes. It's just CnH2n. However many carbons there are, you have double the number of hydrogens. So if there are 3 carbons, you would have 6 hydrogens, and you'd be C3H6. If there were 5 carbons, you would double that, 10, that's 10 hydrogens, so your formula would be C5H10. When it comes to naming alkenes, they end in the letters ENE. And again, the start of the name comes from the number of carbons in the chain. Now remember, there are no alkanes with 1 carbon, so we don't need to know that. But then it follows the same pattern as we had for the alkanes. 2 carbons eth, 3 carbons prop, 4 carbons but, 5 pent, 6 hex, 7 hept, and 8 oct, giving us these ones: ethene, propene, butene, pentene, hexene, heptene, and octane. If you notice, we've got that carbon-to-carbon double bond inside. Now, the final thing you need to know is, how do you tell if you've got an alkane and an alkene? How do you tell them apart? Well, what you're going to do is you're going to do a test for saturation. And we need to know what is meant by a molecule being saturated or unsaturated. Now, alkanes, every carbon-carbon bond is a single bond. If you only have single bonds between your carbon atoms, you are saturated. Alkanes, remember, what makes them an alkane is that they have a carbon-to-carbon double bond. If you have a carbon-to-carbon double bond, you are unsaturated. So only single bonds is saturated. Anything other than single bonds is unsaturated. So how do we test for unsaturation? Well, what we use is a chemical called bromine solution, which starts off an orange color. Now, for alkanes, things which are saturated, when we add this bromine solution to them, nothing happens. The bromine solution stays orange. However, if we were to add the bromine solution to an alkene, something that is unsaturated, the bromine solution goes from orange to colourless. So we can use this test to prove whether or not a hydrocarbon is an alkane, stays orange, or an alkene goes from orange to colourless. Now, there's one final thing that we need to talk about, and it is a process called cracking. Now, cracking is what gets done to longer chain alkanes and alkenes that you might find in crude oil to break them into smaller alkenes which have more use in society. Now, how this is done is that the longer chain hydrocarbon is heated up and it's passed over. That just means you flow it over a catalyst, something like aluminium oxide. And when that happens, the smaller alkenes, which are usually gases, evaporate off and you can collect them. Now, the main product that we get through cracking is the alkene C2H4, which we call ethane. And we can prove that we are producing alkenes by testing them with bromine water. And if the bromine water goes colourless from orange, that means that we know we've produced an alkene. So that has been our video on hydrocarbons.